All right, so that was direct variation. What we're going to talk about now in skill number 7 is joint variation. This is essentially, it's related to direct variation, but rather than having sort of two variables that are moving in sync, you have sort of a multivariable system. So you have, you sort of one output variable, but it's depending on like two or more other variables. There still is a certain amount of, if you sort of increase, you get an increase relationship happening. But because there's more than just two variables, we kind of lose the ability to do a proportion cleanly. So we have to use this constant of variation. So we have kind of extended version, and really just looking at sort of one specific example. This is a connection between engine speed and the gear that your engine is in, and speed of the wheels, right? Sort of wheel RPMs. This is, in theory, sort of a very simplified version of how this all works, right? So you have an engine, and part of what happens to sort of transition you to different speeds at the wheels versus how fast the engine is running is all of the different gears in the car, right? So as you shift into higher and higher gears, it allows the engine to spin more slowly, but you're getting more speed at the wheels, right? Think about, if you sort of watch the RPMs in the engine go up, and you sort of listen to the engine increase and sort of work harder and harder, and then if you have a manual and then you sort of shift to the next gear, you shift up, then the engine sort of and kind of goes back down and then sort of builds up again, right? I guess even in automatic, you can kind of, automatic transmission, you kind of hear this happening, even though it's sort of doing it automatically. In any event, the basic setup here, what we're going to be using is this formula. And so this is 3 variables and then 1 constant. So C is the constant, right? And the relationship here is the wheel speed, W, is going to be this constant times the engine speed, which is our E, times the gear. And so we're literally just using, 1, 2, 3, 4, 5 for first gear, second gear, third gear, fourth gear, fifth gear. And the idea, the way you can kind of think of this is that every different car, every different engine is going to have a different constant here, right? So the way it's sort of put together, you get a different value here for C. So every problem you do, you're going to have a different value here for C, even though the sort of setup for the rest of these, the positioning here, right, the equation is the same. Let's sort of walk through the example that's here in the book, and then we'll do one from the exercises too. So what does this look like? So what they're telling us is the wheel speed of a car in second gear is 500 RPM when the engine speed is 1800 RPM, right? So second gear, that's your G. The wheel speed, right, is 500, so that 500 is your W. When the engine speed, right, so then your E is 1800. So you're given, right, what would be those sort of initial 3 values, so the gear, the wheel, and the engine. You kind of need to just be told initially what all 3 of those are to be able to get started. You sort of need to know that to be able to actually sort of calculate and figure out what the engine's constant is, and then you can apply that constant to a new situation. So what they're asking us to do is, so when the wheel speed of the same car, right, find the wheel speed. The same car when you're in third gear and the engine speed is 2400, right? So that's the change up. Couple different ways we can approach this. Our sort of initial formula, right? The wheel speed is going to be the constant times the engine times the gear. So this is all for sort of situation number 1. What we want is the constant, right? We want this engine constant, whatever this sort of value C is. We can't really do anything without it. So the idea is if you solve for C, you could do a quick just division, divide by the sort of engine and the gear. You would sort of rearrange it just like we did in skill 6, right? Or sort of rearranging formulas section. So the constant here should be the wheel speed divide by the engine times the gear, right? The engine speed times the gear, just kind of rearranging this. You can put the numbers in first if you want to. It's, this is sort of an algebra version first, and then the numbers go in after. Either is fine. So sub all those values in, right? So these are our sort of red. Maybe I should have tried to keep this consistent, right? So my initial values, right? My wheel speed is 500. Second gear is 2. The engine speed is 1800, right? So if I crunch this, 500 over 2 times 1800, 2 times 1800 is like 3600. So 500 divide by 3600, 0.138 repeating, aka 139. So that's the constant, right? That's what you're trying to solve for. That's that value C. So that means you can use that in your sort of second situation, right? Let me carry this up. So we sort of reboot, start over again, right? So the C that I just found, right, I'm going to sub in here, right? So 0.139 is my engine constant. Engine speed, so this is in situation number 2, right? So the engine speed now is 2400. Engine speed 2400, and then we shift it up to third gear. So what happens is, if once we know all this stuff, we can just sub it in and multiply. So 0.139 times third gear times 2400, right? 100. Whoops. Oh, 240 times 10, right? 1000.8. Bingo. So that's my speed at the wheels. If we wanted to extend this into a giant problem, you could sort of take what were some of the concepts. Which skill was that? Skill number 4. Talking about sort of RPMs versus linear speed, right? That sort of angular speed, which was sort of our rotational speed, the RPMs. So this sort of wheel speed, you could then sort of take it one step further, look at the size of the wheel, and if you know these RPMs, then you know the size of the wheel. You could even sort of take that and convert it into miles per hour to find an actual sort of linear speed. Or you could look at your dashboard. That will tell you the value too. Let's look at another one from the examples. So I want to jump back to number 7. The way the exercises in this chapter work, there's some direct variation. There's these sort of joint variation problems here in the middle. And then there's some more direct variation afterwards, right? So it's sort of a direct variation sandwich. Or is it a joint variation sandwich? The sandwich is what's in the middle. Peanut butter and jelly sandwich. Peanut butter and jelly are in the middle. This is a joint variation sandwich. The joint variation problems are in the middle. The question here, so it's the same concept, but the setup is just a little bit different, sort of what we're asking. So Porsche 911 Turbo observes the best gas mileage when the engine is running at 1700 RPMs. Everybody knows that. Even young children know that that's when this particular Porsche gets the best gas mileage, 1700 RPMs, right? So that's your sort of ideal engine speed for saving some money. If the wheels are spinning at 2920 RPM and the engine is turning at 5100 RPM in first gear, right? So that's setup number 1. What gear should the driver be in to get the best gas mileage when the wheels are spinning at 2920 RPM? Okay, so let's just sort of write all that information down, and then let's like piece it together. I did that already, actually. So we get the best mileage per gallon when the engine is at 1700 RPM. So that's our goal, right? Situation number 1 was the wheel speed is 2920. The engine is running real hot at 5100, but that's because you're in first gear, right? So what is the gear that you want, right? What gear will give the ideal miles per gallon when the wheel speed is 2920? So if the wheel speed is 2920, what's the gear you're after to get 1700 at the engine? So, right, initially you need this like baseline information because you've got all these variables working together in league with the constant. So you need all that stuff first. So let's just sub it in, right? So I know this is right. So my wheel speed is the constant times the engine times the gear. So this is 2920 is the constant times the engine's running hot, 5100 times first gear. Okay, so that's a pretty simple equation, right? This is literally then just, well, 5,100 times 1 is, of course, 5,100, right? 2920 comes down. So to solve for this constant, I just need to divide the 5,100 over. So my constant, oops, sorry, I always got to remember to keep sliding this up as we go. So my constant, 2920 divided by 5,100. So 0.572, 0.5, well, 5725, so 0.5, we'll call it 0.57. Okay, so that's my constant sort of for this engine, right? So we said, of course, these constants are going to sort of be different for each engine. So then situation number 2, whoops. I said 2, but I wrote 1. That's not so helpful. Same equation, right? My wheel speed should be the constant times the engine times the gear. So let's plug this stuff in. We have the wheel speed is 2920. The constant which we just found is 0.57. This is me realizing, of course, that the wheel speed is the same in both of these situations. We're trying to go the same speed. We're trying to figure out what gear we should be in. A little bit slow in the uptake this evening. So 2920 is constant 0.057 times the engine speed, right? Which we said our ideal engine speed is 1700. Right? So I want that to be 1700, and then that's going to be times the gear, right? So the gear is what I'm actually solving for here in the end, right? That's like my X. So all I'm going to do, let's multiply 0.57 times the 1700. Times 1700. 969, right, times the gear, 2920 on the other side, of course. To solve this equation, get the gear by itself, we'll divide by the 969. My guess is this is going to be very close to 3, of course. The only way this makes sense is if it hits essentially on a whole number. We can't shift into 3 3/4 gear. So 2920 divide by 969. So 3.013. Effectively, 3 is our gear, right? It doesn't make sense to use that full decimal there. Obviously, you just sort of want this to be whole value. So that's the basics. That's the idea, right? You can kind of use this a couple different ways to sort of solve these equations, deal with this scenario. So the idea here is this is joint variation. It's these different variables, not just 2 of them, but in this case 3. In theory, I guess you could extend this to sort of even more than that. You just have a longer equation and more work to do. So there you go. Skill number 7 in the books.